Potential energy, PE, is mgh, where h is the vertical height. Kinetic energy, K, is half mv squared. Energy is scalar. Unit of energy is also joule. A block of 2 kilograms is moving on a horizontal surface at 3 meters per second. Find its potential and kinetic energy. PE is 0. Ke is half times 2 times 3 squared, which is 9 joule. A ball of 1 kilogram is 3 meters above the ground and moving vertically up at 4 meters per second. Find its potential and kinetic energy. P is mgh, which is 1 times 10 times 3. It is 30 joule. Ke is half mv squared, which is half times 1 times 4 squared. It is 8 joule. Find the potential energy of a block of 1 kilogram sitting at the top of a slope of 2 meters inclined at 30 degrees to the horizontal. H is the vertical height. The slope is 2 meters long, so its height is 2 sine 30, which is 1 meter. So P is mgh, which is 1 times 10 times 2 sine 30. It is 10 joule. The work done by the sum of all forces acting on a particle equals the change in the kinetic energy of the particle. A ball is projected vertically upwards at 10 meters per second. Find how high it can reach. Initial velocity, u, is 10. Final velocity, v, is 0. Acceleration is minus g. One way is to use the formula, v squared equals u squared plus 2as. Put in all values, we get s as 5 meters. We can also use the energy approach. Initial Ke is half m10 squared, which is 50 m. Final Ke is 0. So change in Ke, delta Ke, is minus 50 m. Only weight is acting on the ball. And since weight and displacement are opposite directions, work done by weight is minus wh, which is minus mgh. Work done is delta Ke. Therefore, minus 50 m is minus mgh. So, h is 50 over g, which is 5 meters. A block of 1 kilogram moves 3 meters down from rest along a slope inclined at 30 degrees to the horizontal. The coefficient of friction is 0.5. Find its velocity. First, we sketch the force diagram. There's weight W, normal reaction R, and friction. Then, resolve weight on 2 directions. Vertically, using Newton's first law of motion, W cosine 30 is R, which is 5√3 Newton. Horizontally, using Newton's second law of motion, W sine 30 minus friction is ma. Friction is μr, so A is 5 minus 2.5√3 meters per second square. Initial velocity, u, is 0. Using the formula, v squared is u squared plus 2as, we get, v equals √6 times 5 minus 2.5√3, which is 2.00 meters per second. We can also resolve it with the energy approach. Displacement s is 3 meters down along the slope. Initial Ke is 0. Final Ke is half mv squared, which is half v squared. The angle between weight and displacement is 60 degrees. So work done by weight is, Ws cosine 60, which is 15 joule. Friction and displacement are opposite directions. So work done by friction is, minus 2.5√3 times 3, which is minus 7.5 root 3 joule. Normal reaction is perpendicular to displacement. So work done by normal reaction is 0. Work done is change in Ke. So 15 minus 7.5 root 3 is half v squared. And we get the same result. In this class, we learned potential energy, Pe, is mgh, where h is the vertical height. Kinetic energy, Ke, is half mv squared. Unit of energy is joule. All work done is change in kinetic energy. Sigma W is delta Ke.